Basic Calculus, Module 15, Related Rates. One of many important applications of derivatives is related rates. This is essentially the study of how two or more quantities that change with time are connected and can be linked with an equation in which the relation of the rates of change may be found by differentiating both sides of the equation. Solving problems related rates needs a systematic approach, from determining the relationships between quantities to using implicit differentiation when we examine the rates of change of all quantities with respect to time. Here are some sample problems which may help us to know better how to solve for related rates. Let's study this first problem. A 30-foot ladder rests against a vertical wall. If the bottom of the ladder is sliding away from the base of the wall at the rate of 5 feet per second, how fast is the top of the ladder moving down the wall when the bottom of the ladder is 10 feet from the base? Now we let x be equal to the distance of the bottom of the ladder from the base of the wall, and y be equal to the distance of the top of the ladder from the base of the wall. We also let the value dx over dt be equal to 5 feet per second, or 5. Now we need to find dy over dt when x is equal to 10. We solve this equation by using the Pythagorean theorem, x squared plus y squared equals 30 squared. Then we substitute. We perform the equations, then we square both sides. We get the values of y, which is 20 square root of 2. Then we differentiate the equation. X squared plus y squared equals 20 squared becomes 2x dx over dt plus 2y dy over dt equals 0. Then we substitute the values. Dx over dt equals 5, x equals 10, and y is equal to 20 square root of 2. Then we get that whole equation. We equate it to 0. Then we transpose positive 100, it becomes negative 100. Then we cancel 40 square root of 2 to get the value of dy over dt. Then the answer is negative 0.03. Let's try another example. A man 6 feet tall is walking away from a lamppost at the rate of 50 feet per minute. When the man is 8 feet from the lamppost, his shadow is 10 feet long. Find the rate at which the length of the shadow is increasing when he is 25 feet from the lamppost. Now we let y be equal to the length of the man's shadow, x equal the distance of the man from the lamppost, and h equal to the height of the lamppost. We need to find dy over dt when x is equal to 25 feet and dx over dt is equal to 50 feet. We use the similar angles formula, h over x plus y equals 6 over y. When x is equal to 8, y is equal to 10, h over 18, which we add 8 plus 10, equals 6 over 10, which is the value of y. Then we cross multiply. H will become 10.8. Now we substitute the values of h. 10.8 over x plus y equals 6 over y. Then we cross multiply again. 10.8y, 6x, 6 times x, 6 times y, 6x plus y. 4.8y is equal to 6x. We transpose 6y and then we subtract. The whole equation will become y is equal to 6x over 4.8, wherein we cancel 4.8 from y. Then we perform. Y is equal to 1.25x. dy over dt is equal to 1.25. We differentiate 1.25x. Then equals 1.25 times 50, which is the value of dx over dt. Then we solve and we get the answer 62.5 feet per minute. We have a similar problem, but with different values. A man 9 feet tall is walking away from a lamppost at the rate of 10 feet per minute. When the man is 10 feet from the lamppost, his shadow is 20 feet long. Find the rate at which the length of the shadow is increasing when he is 45 feet from the lamppost. We let the values of y be equal to the length of the man's shadow, x the distance of the man from the lamppost, and h equal to the height of the lamppost. We need to find dy over dt when x is equal to 45 feet and dx over dt equal to 10 feet. Using the similar triangle formula, again, h over x plus y equals 9 over y. Using the formula, we substitute the values of x equals 10 and y equals 20. So it becomes h over 30 equals 9 over 20. We cross multiply, then we get the answer of 13.5. You substitute it again. Then we cross multiply. We get the answer. We perform the equation, then we get the final answer. dy over dt is equal to 2 dx over dt equals 2 over 10. 10 is the value of our dx over dt. Thus, our answer is 20 feet per minute.